So this week I'm going to jump into talking about a couple of attacks. We'll actually demonstrate them for all of you using some of the tools that are available. I'll make these tools available later on. This, you know, the first slide deck I had from week number 1. Constant sound. Okay. That's weird. Okay. Yeah. There's actually nobody talking in class. It's quite interesting. Let me try turning down the microphone settings and see if that helps. Actually, let me try something. Very well could be that the microphone is getting some interference, and if I turn it down, it might solve something. Is that any better? Okay. Yeah, if anyone on the class, like who's connected remotely, has audio enabled, can you make sure that you turn it off? Unless you're trying to speak. Like, yeah. Basically, send me a chat if you want to speak. What's weird is I'm not actually hearing any of the audio in the room today for some reason. So actually, yeah, remote audio today may not even work because it doesn't sound like the speakers in the room are working. Like, I've got the... Anyway, sorry. Alright, thanks. So, jumping back to this. Yep. Oh, and now this is off the screen for some reason. Okay. So, I'm going to go over some attack information today. Basically, we'll talk about how malware is employed in attack. I felt that rather than trying to dive into this halfway through the course, is probably a good experience to see it in action ahead of time, even if I don't have time to go into every single tool and what its capabilities are and how it works and everything like that. But the end goal for most malware is to try and get software on your system, as we talked about during the first week, that provides the adversary some advantage to being on there. So for instance, they can steal information. They can steal your credit card numbers. They can impersonate you. They can cause damage to you, which might have kind of a side effect of a net benefit to them. For instance, if they don't like the company you work for, then making your day difficult might make them happy for some reason. So the Kali Linux is what we'll be using to build an attack. It comes with Metasploit, as part of the, as one of the tools that are available on it. There's also a number of other attack tools as well, like Armitage and stuff like that. I'm not going to go over a whole bunch of them. I'm going to use some basic ones because really we want to be able to put together malware that then we can take apart and analyze in this class later on. This way. So why learn attack? This is, I kind of summarized a lot of this. the big thing to keep in mind here is a lot of times the software that's being used for attacks, maybe like half the time, is actually has legitimate use and legitimate purpose in a lot of cases. So for instance, there's a number of tools for doing port scanning and stuff, which allows you to, if you run it on a computer here, you can use it to discover other neighboring computers. That's actually a really common administrative tool to use in a lot of systems, but in the context of some environments or in the context of some other activity going on, that might be malware. A lot of times, attacker may also need to, self-analyze their own malware in order to decide, like, this is a really great one too, what modifications need to be employed to sidestep target side mitigation. So if they're trying to attack you, or if they're trying to attack someone, so for instance in red team type environment or pen testing, that type of thing, they may need to analyze their own malware, figure out what component of the malware is being prevented or is being detected in the environment that's preventing their attack from succeeding, and actually modify it. So the big thing here is we want to find out how the tool is being used by the attacker, and being able to kind of have some experience with actually seeing that happening is the first step in that direction. So it also kind of gives some hints, or I should say gives some insight as to what it is you're going to be looking at in the lab environment and where you're going to be looking to analyze what the malware did on a system, or possibly how you could find it on a system. So I gave you a really brief experiment. I think we played with like Netcat and and did some random sysadmin type stuff. So I have like the shortcut to how to get it imported if you haven't done it already. I just posted that OVA image earlier today. So I'm going to use this. I'm going to add stuff to it as class goes on. So anytime I update that image, I'll let you all know. So there you go. And then these are some nice tools that are included with it. So we're primarily going to use the first one. Some of you might have used the second one in another class. But all of these are great tools to play with. You get proficient with those tools, and they're a really good foundation for a lot of kind of security assessment and penetration testing work. And so we're going to try and put together what I call a really basic remote shell attack. What that is you're trying to get access to access to a system so that you can maybe use that for access later on. In this case, I talk about this in terms of like a PDF attack. I'm probably going to just do one attack, and it'll be shockwave flash instead. So we'll do a little bit different analysis, or I should say a little bit different attack strategy than what's on this slide. I actually have some other slides coming up later that talk about the attack that we'll do first. If I still have time afterwards, then I'll put this one together as well. But that attack is actually available on the videos on the website, so I figured I wouldn't recreate it in class. I'd actually do something new. But a lot of times I call this reverse shell, and what it is if you're familiar with, and I'm just gonna, if you're familiar with doing this, let me share this application. So if you're familiar with command line, commonly the command line is, what's called the shell. So you can type commands back and forth, have it, it's basically interactive shell. So you give it you give it commands and then it gives you results. So there we go. Yeah. Oh, let's see. Can I change the background of a shell in Windows? Probably. Colors. There we go. This. Then this. Then this. See if that works. Looks a little bit better. We'll try and do this as well. Do this. Much easier to read, right? So there we go. So this is basically like your normal command line, right? So you can type in commands, etc. So they call it a shell. So basically, we're going to do what's called a reverse shell. And the reverse shell is that I want to exploit this. I want to exploit, a remote computer, and then I want that remote computer to come and connect back to my attacking machine. And then I want to have a shell, an interactive session like that, command line session, that allows me to interact with that computer from my own computer, so from the attacker's computer. And so it's called reverse shell because I'm actually causing the target's computer to open a connection to my server and then provide me with the shell, versus me trying to open up a shell on my computer and then connect it, like the traditional concept that many of you are familiar with would be like remote desktop or something like that. You can open a graphical remote desktop, but you can also open a command line remote desktop, or like SSH. That would be like a direct shell. So reverse shell is having the system connect back to you and then give you that shell. So the process for this, and again, as I said, I'm going to vary on this, and I actually have some slides later on talking about it, but this is the really classic attempt. So I'll give this to you now. The big one is that you're going to want to set up a remote control listen service. This means that I, the attacker, I need to have a computer that is not just able to access the internet, but is able to be connected to from any other machine that has internet access. So I need a machine that has a public IP address, for lack of a better term. I'm going to need to create a payload. So naturally, on most computers, there is not some arbitrary tool that's designed to just connect out to some random machine on the internet and then give it a shell. I actually need to build a tool that does that. And I need to build a tool that opens up that shell and then is also encoded with the instructions to talk back to the listen server. So these are all components of malware that I'm going to have to build together as an attacker. So this right here, these two top ones, or I should say this second bullet, that itself a lot of times is a program, or sometimes it's just like a little code snippet or what is called shellcode sometimes. A lot of times it's a full program. So this third one is embed that payload in a carrier or Trojan. I always like to use the word Trojan. We'll get into terminology later on as well. But basically, in this case, the one that I videoed last year, I put it inside of a PDF document. So I had a PDF document. I believe the topic had to do with like funny cats or something. So something that obviously, if I emailed it to anyone, they would double click on it immediately. So the idea here is to put it inside of a Trojan. It's borrowing the terminology from the Trojan horse. Those of you who've taken the information assurance class here, you probably have used a book that has a big Trojan horse on the cover. But basically the idea with that was that, they gave the horse as a gift, but the horse secretly had an army inside of it. Once the horse was taken inside of the castle, the army broke out of the horse in the middle of the night and killed everyone. So that's the same idea here, is you give the user something they think will benefit them, like a PDF document that's full, that says it's full of a bunch of cat pictures, but unbeknownst to them, hopefully, it actually has this program embedded within it. And so it's also got an exploit buried in it, and that's another piece of malware. That exploit basically breaks the PDF reader and executes this program in order to basically initiate that reverse shell back to the user. So from my perspective, from the attacker perspective, I follow these steps in the process. So after I've built this Trojan document, I deliver it to the target somehow, and then I somehow convince them to open the PDF. So I say social engineer, because for instance, you know, how do you get somebody to open a random PDF? So like a great example might be if you happen to, if you happen to be able to find this person on LinkedIn or Facebook or something like that, can you find maybe another family member of theirs, something like that? And then can you find that family member's email address? If you can find that family member's email address, it's very trivial to forge a message to look like it came from their family member that has that PDF attached to it, with a simple message body like, oh my God, look at this, LOL. And honestly, that would be a probably more sophisticated approach to attack than what's really needed for success in 50% of the cases. But that's a, kind of off the top of my head, trivial approach to social engineering it to get them to open it. And basically what it is, you wait for them to open, you just kind of leave this listen server waiting until they open the document, their system's broken, and then connects back to you and gives you access. So in the real world, research for a successful attack can take weeks or even months. And we'll go into why this is when I'm kind of going through the, when I'm going through the Metasploit and looking at the modules and everything. But, so I'm going to say here that this is kind of a caveat to a lot of the demos that are going to be in class. And this is also the case with a lot of the ones you'll find online is it's pretty unrealistic for like me to try and create what are called zero-day attacks like in the middle of class for you. So a lot of times people will take months or even a year or something like that to try and research those. So what we will focus on is a lot of attacks that are targeting vulnerabilities in known old versions of software. So you'll see me using old versions of Windows, old versions of Acrobat Reader, old versions of Shockwave Flash. And you can actually get a lot of these old versions of software online, and probably out of scope for class today, but we'll probably talk about how to find these things during next week's class, because actually being able to identify, being able to evaluate malware running in different versions of software is also very helpful for malware analysis. So we'll analyze attacks that are already known and mitigated against. So if you are running the latest Windows 10 with the latest Windows Defender updates, the latest version of McAfee antivirus or Symantec antivirus or whatever you're using, then chances are that anything that happens in this class is not going to be very effective against those types of systems. So that's why I have a lot of these specialized VM lab environments for for us. So a lot of times when an attacker is, say, going at a target, they have a lot of mitigations and basically constraints they're working within. So antivirus software, OS level kind of environment randomization or entropy, newest versions of application software, updates, closed known bugs, et cetera, and then also you can read a lot about, say, CERT and CCERT and stuff like that. If you haven't learned about those things in some of the other classes here, that are basically how to structure security teams to identify and then remediate, compromises and attempts at compromises when they end up in the network. So I'm going to go and jump to this one, and then if we still have time, I'll jump back at these, right? The basic browser and Adobe Flash plugin attack template. So we're going to use the Meterpreter shell. We're basically going to use the same. So if any of you have looked at the video, we're basically going to be using the same payload. By default, Metasploit, for the most part, has a default payload that it uses. And that's, I think, one of the ones that was used in this example. So we'll end up using the same one here as well. We'll just be changing the attack to use something that's probably a bit more modern than phishing with a malicious PDF. So what we're going to do is I'm going to have a Adobe Flash plugin, which, many of you are probably familiar with, that Adobe Flash is expected to be probably deprecated in the next few years or something like that. But it's a very popular attack strategy, and one of the big reasons for that is, let's see right here, Flash advertisements. So a real common vector for malware for many years has been those banner ads and stuff like that you'll see, mainly because the way that a lot of them work is that they have a lot of advertisers that will basically give them either an HTML snippet or a small Flash program or something like that, which then they keep in a large directory of advertisements, and you pay them for how frequently you would like your advertisement to randomly show up. So that's always been a really popular vector because it's something that it's the cost, or I should say the investment's easy to balance. You can pay more or less. And then also, if you don't care about where the revenue is going or something like that, then and you just care about the hits, then a lot of times there's a lot of advertisers out there that are more than willing to take the money up front for the service. So the other thing, AWS or other mechanisms. So if you happen to have, again, you're definitely going to need some infrastructure that's hosting that server that I mentioned up here, right? So this listen server that I got in italics right here. You're going to need something on the internet that's publicly available for that. Likewise, if you are providing a Flash animation or a Flash advertisement, a fake advertisement to someone, the way that most users receive those is not via attachment in email. The way that a lot of users receive them is, via websites and web pages and everything. So you're going to need to have infrastructure that you can host this on. Thankfully, there's a whole bunch of options, including, you can set up websites on GitHub like I do with the course website. You can get free web hosting from Blogspot, from a whole bunch of other, free content hosting sites out there. So there's a lot of options for the adversary. A lot of times the adversary might also compromise a web server that's maybe owned by a small warehouse company or something like that, and host a Flash animation on there. But the goal is that once they do that, then they basically send an email. This actually broadens the number of attack vectors as well from just being email, because up here with the PDF attack, one of the things with the PDF is that the primary way that you typically get delivered a PDF is usually by email attachment or something like that. It's near impossible to text a PDF to someone, or to even send one via Facebook Messenger or something like that. But things that are sent very commonly through chat applications and through texting and through all sorts of other basically conversational mediums is links. So the other thing too is that links are also fit into the whole advertising malware as well. So I have some, I borrowed some of the content in this example loosely from these things, or I should say I used them for inspiration. So feel free to go through those. They kind of talk about some of this stuff, talk about some like meta exploit tools that are in Metasploit. This first link, though, the Ars Technica one, this is actually a breakdown, and I think that's probably one of the few links that I'll be able to actually visit in, whoops, see, might actually be one of the links that I'm able to visit here. Let me get this, open a new tab. So I'll show you. So some of you may or may not be entirely familiar with this. Was a company that actually sold not just pen testing services and software, but also attack services and software for a legitimate I should say, what is widely considered to be a legitimate commercial purpose, or what we will call gray area. So if the laws around like espionage and stuff like that in particular countries are loose enough, then you can literally sell espionage software, and then the burden is put on the targets as to how well defended they are willing to be or not. So a large number of folks actually were found to have hired the services of this company hacking team to basically gain access into gain unauthorized access into companies, private organizations, individuals, etc., globally. So I think there are a handful of governments, and I'm not going to try and name them off the top of my head because I can't remember them, but there are a handful of governments and at least like political parties and other like private organizations as well who were found to have been using this because somebody broke into this company, so somebody hacked the hackers, and then they went through and not only stole all of their tools, they analyzed a bunch of their tools and dumped that analysis up on the internet, and they also dumped the customer lists as well on the internet. So when they analyzed the tools and they analyzed their exploits and all that stuff, one thing they found was a flash exploit. So this was right after Adobe had put a huge amount of effort into trying to make Flash more secure and everything. This is also a really great example of how you can dump a large amount of money into securing something, but it's very, 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 very difficult in today's kind of software landscape to get anything truly secure. So the release of this ended up putting into the public domain a number of private exploits that hacking team had been using to basically provide their customers with the unauthorized access they wanted. We'll actually use some variant of the public exploit for the example in this class. Yeah, so they also have some discussion about some other vulnerabilities as well that were going on that they were researching. So let me go back to the slides now. So let me see. So that's the first link that has a really good analysis of not just what happened and what was released, but also this particular Adobe Flash 0-day and some high levels about how it worked. I believe there's some references in there to some more technical documentation as well. And then the rest of these are just kind of some tutorials and some references around using some of the Metasploit modules that we may use. So I'll get to that in a second, but after after kind of initial access is provided, a lot of times it's really common for them to bring other tools, and so I have a few other tools up here as well. Sorry about that. So I have a few other tools up here as well that I'll also get into employing for this demonstration. But I'll jump right into it. So I've got, let me just double check the settings on this and make sure I have it configured properly. I always do this. Sure. Okay. So here's the VirtualBox window. It's kind of picking up from where we were earlier on, and on Tuesday. So I'm actually using what's called the host-only adapter mode. So I don't know. This is. Let me just do this. So I'm going to use the host-only adapter mode. What this requires us to do is I'm going to exit out of this a second so that I can show what I need to do. So I need to go here to the file menu of VirtualBox and mess with the host network manager. And basically I needed to create a new network. And when it does that, this actually will, here. Yeah, I'm going to open up network settings for a second just to kind of show you. So this actually creates this. Creates a network adapter. So it actually, the one that I have selected up here in the window, it creates a new virtual network adapter. So we messed with internal network last session, and I explained that allows you to create a network that's completely hidden even from the host. This actually allows you to create a network that's completely a virtual network that's completely hidden from your, say, company network, but it gives you a virtual port or a virtual connection to that network on your host. So for instance, if I wanted to, I could actually try connecting directly to the, I could try connecting directly to one of the systems from my, go over here, from my, from my laptop, from my host machine if I wanted to. So that's all set up. The other thing too that it allows you to do is it allows you to use DHCP server as well, so you can automatically give IP addresses instead of having to manually set everything, which can be very convenient if you have to build up and tear down and you don't know exactly what your network layout's going to be. So I actually have two of these systems, so I cloned my Windows 7 VM, just like I kind of demonstrated last session as well. So I'm going to kick off the Kali Linux, and I should already have the Metasploit console up. So I have the Metasploit console up right now. And basically, I ran MSF console. So as I said before, there's some like setup stuff that you may need to do. I set it up so that so that it would work. And then the other thing that I just made sure that I was doing is the network settings here, set host only adapter, and then they choose that one that I created right here. So I'm running Metasploit. So the first thing that I'm going to need to do is I want to find out what's my IP address. So if I was to like have randomly plugged this into a public access network or something like that, I might have an IP address there. Since I'm in control of the network, this is kind of the first step to finding the IP address. Since I'm kind of in control of both sides of the network here, I'm going to be able to use this internal address for what I want. So this right here is my IP address. So I'm going to save it because I want to remember it for later, because that's the address that my listen server, the one I was telling you about, is going to run on. So then what I'm going to do is one of the nice things about this is you can search for things like, you can search for certain, attacks to use if you want. So for instance, I can search for Adobe PDF, and I can see a bunch of attacks that are related to Adobe PDF. If I just search for plain old PDF, maybe that changes. It looks like I get a bunch more, but maybe not all of them are actual PDFs or actually targeting Adobe's PDF reader. I can also look for Adobe Flash, which is going to be more up the alley of what I'm trying to do. And you can see that when I do that, I have this really nice table of all of the all the exploits that are available in the database here. I'm going to go up to the top. And so basically, again, this kind of gets to a bit of the output products of malware analysis. So basically, you have all these different exploits. So they identified a vulnerability in a particular piece of software. And you'll want to look at the ones that start with exploit. So just to kind of give you a heads up, there's more tools in Metasploit than just exploits. So searching for, say, an application like this will sometimes bring up some of those other tools. So the top one, I'll get into it later, but it's kind of like a scripting tool. But basically, there's vulnerabilities in software. What the Metasploit team tries to do is they try to come up with at least one exploit that's designed to be successful against that vulnerability. So there may actually be multiple exploits against a particular vulnerability. Yeah?
So this database is like from Metasploit, and it's like built in the Kali, or it's like
yeah.
a separate tool? Or?
It is distributed with Kali.
Okay.
So.
But it's like the Metasploit, like the database?
So Metasploit's just the name of a piece of software, and that piece of software has a database along with it that's basically an archive of all these things. The archive of a bunch of, so it's sold for people to try and do penetration testing and red teaming, basically. So to try and, so somebody spends a bunch of money to build something that's supposed to be, very secure. Then they may pay somebody to validate that it's secure. People using Metasploit will frequently be ones who are supposed to try all the exploits they have access to validate whether some company is secure or not. That said, a lot of malicious people also use Metasploit for breaking into people's systems. There's actually an entire API for writing these things too, which I'm not going to get into in this class. I do think that there's sometimes a network exploitation class that goes on that may involve that. I'm not entirely certain. Anyway, the one that I think I'm interested in is this one. So this one is a Adobe Flash hacking team byte array use after free. So that basically means that if any of you are familiar with C, you can malloc memory, and then after you malloc memory, you're supposed to free memory in order to make conservative use of your virtual memory for your application. So if you are efficiently using memory, you're using malloc and free to make sure that you keep your program's memory footprint at a minimum size. So what's happening here is that they found a vulnerability in Adobe Flash where after a buffer has been freed, then some other part of the code tries to use the contents of that buffer, even though it's supposedly been freed. So basically, they violate, they violate memory, I don't say protections, but they violate memory usage. So What we will do is we'll go and grab this. And then it's actually pretty easy. You just say use it. And then I'm going to use it. And then once I do that, I can actually have it, options. I can run show options, which is what I typed up here. And then it will actually show the options that I can use to try and configure this. So in a nutshell, what's going to happen here is that Metasploit's actually going to build a Flash animation or Flash file in real time based upon the parameters I put in here, such that that Flash file will actually compromise the target system, so compromise anybody who views that Flash file, and then run a program on that computer that gives me that reverse shell that we wanted to talk about. So I need to tell it where to send, or I should say where to host it. So I'm going to change this. Oops, to 192.168.56. Or no, what was that again? 3.5.4. So I'm going to change the host server to that. The other thing, correct. That's my Kali Linux machine, right? The other thing that I'm going to want to do is this is going to be hosted. So it wants to come up with a page name, or wants you to give a page name that the web browser has to visit in order to be served this Adobe Flash. So what I'm going to do is I'm actually going to go and give it a a predefined path. It randomly chooses one if I don't put anything in here, and that can be kind of painful considering that I can't copy paste from my Linux Kali VM into another Windows VM very easily, or I should say very safely. So what I'm going to do is I'm going to set this to, I'll just set it to page, something like that. And then I can show the options. So then what I can do after this is I want to give it a payload. So remember, the attack typically has two pieces. It has the Trojan and then it has a separate payload. So the Trojan is the package that delivers a payload, which is delivers the malicious malware or whatever to the system somehow. So the Trojan typically looks like something the user wants, and then the malware typically is usually identifiable once it is discovered on the system as something the user doesn't want. So rather than go through the entire payload database, I'm just going to use the default payload here because it makes things very easy. And if I do run, and then I kill it after it runs, but you'll get to see, it'll actually show you a quick thing. This ends up being a lot easier way of doing this. So it tells me this. It'll give me a warning. This is actually a really common thing, which is part of the reason I just included this in the demo, is that by default, it configures the listen server as being localhost, as being 127.0.0.1, which means that when I deliver the application right now to the target, to the Windows 7 VM, the Windows 7 VM is going to try and connect to its own localhost address. So with the default payload again. So I just ran show options again, and what you can see is that it actually brought up the Meterpreter payload. So this wasn't in, these lines weren't in the previous run because I hadn't selected a payload. So I found that an easy way, if I just want to use the defaults, is just to run it and then stop it or kill it, which I'll do in a second, and then give it new commands, or give it a new parameter. So what I'm going to do is I'm going to set lhost to 192.168.3.5.4. So now it's set to that, and then what I will do is I'll kill 0, and then I can rerun like this. And now you can see that it started the handler right here. So now it's listening. And if I want to verify that it's listening, I can actually run this, and lo and behold, you can see that it's up there. And as you remember, Linux automatically converts my IP address to whatever my host name is. So this Kali is actually the external IP address of my server, or my Kali Linux instance. So I verified that it is in fact listening for incoming connections. And it tells you here where to send, where to send the target. So the other thing that I'm going to show you is this, which is info. Info tells you a bit about this module. And one of the things that they tell you, many of them do this, but it's not always guaranteed. But many of them tell you this, is what systems it has been tested on. So it says Windows 7 SP1, 32-bit, and Adobe Flash version 18.00194. So what I'm going to do is I'm actually going to run this version of, I'll go here and I'll go to settings. I'm going to go and do that shared folders thing, because what I've done is I've collected some installers, so the installation packages for different versions of Flash Player. So you can actually see them all there. I've got a whole bunch of different versions of Flash Player. And I'm going to actually install it on the Windows system. One of the nice, failed to save the settings because I think I suspended the machine instead of, so I'll just cancel this. Give me a second. I'll start the machine up, and then I'll do when the machine's running, I can change the shared folders. I have no idea why it doesn't like it if I change the shared folders while it is, suspended. Here you go. So I just brought up the Windows VM that I'm going to be targeting, right? And then I went in and I'm going to set the shared folders. So here's that. Downloads. I just created a folder named hacking because that seemed like the most obvious choice. And then, as we discussed last class, I'm going to open up this, and then I will just navigate to the, okay. Let's see if it's, oh, this is actually still coming up. Oh, you know what? I may have, give me a second. There it is. Okay. Should be working then. I'll bring it up. And then hopefully it should get an IP address. And if it doesn't get an IP address, very shortly I will manually give it one. I'm not going to say. Good. Okay, there we go. Got an IP address. So I'm good now. Go here. Okay. We'll just do this. I don't care about the security that much, so. And for some reason, it's still not doing the I'll just do this. So apologies for the complication here. I should this might be something where this isn't installed yet. I might just have to quickly reboot, which shouldn't take too long. But basically what I'm doing is I'm, in order to get that shared folder thing working, so that it's just easier to shuttle files back and forth between the virtual machine and your host, you have to install this guest editions package, which there's an easy button for getting it inserted, because it actually ships itself as a virtual CD image with a VirtualBox. So there's an easy button for getting it inserted, which is right here in the devices menu. And so that's what I'm doing right now, is I'm just installing that driver. So once I get that installed, once I get that installed, then we should be good to go. Go ahead and reboot later. Reboot now. It shouldn't take too long. It's not like it's Windows 10 with a million Windows updates or something like that pending. So if I remember, this reboot should be pretty quick. The nice thing is that I have, Metasploit's designed so like I can have it running in the background, like it is working right now, and it's basically going to be sitting there, listening for as long as I want it to. It's really designed so that to support both like kind of the active attack as well as the attack where there might be some sort of delayed connection, where it may take like even days for your target to try and get, open the document or visit the page or something like that. So now I can go here and hopefully guest editions working. So here we go. So this is what I was looking for. And then this. And then what I'm going to do is I'm going to install that version of Adobe Flash Player. So I'm actually going to be installing it to run as a plugin on Internet Explorer. The way to identify that is there is this one that's WinAX, which means WinActiveX, and then this one, which is just Windows. And so this one, if you want to target Flash Player running on Firefox, or basically anything that isn't Internet Explorer, you can install this one. If you want to target Internet Explorer, you have to install this one with the AX. So the reason for that is just the extension format is different for Microsoft's tool versus anything that was built for Firefox, or I should say anything that's built in the Mozilla engine. So again, this thing also wants to do the whole like, do you want updates? So I'm going to choose done. And I actually told it never to check for updates. So now, one more thing that we talked about as well is I would like to go to here and then make sure that the firewall is actually firewall. So I'm going to go to Windows Firewall, and I actually want to turn Windows Firewall off. So I'm going to turn it off. Otherwise, it may be difficult for me to do anything. And the other piece that I'm going to do is I'm going to go over here and go to Windows Defender. And that tool, while it's not a firewall, it's actually a type of antivirus. And if I remember correctly, I can go here, and then I turn this off, and turn this off. So basically go through here and turn everything off that it may be doing. So the restore, this thing also does, and also they use this program. So this thing also does what's called like a system restore points, system restore save points and stuff like that, which those aren't necessarily going to interfere with malware, but VirtualBox already provides you the ability to do that. So that ends up just being something that ends up running in the background, causing extra resource utilization and everything that you probably don't want. So now I'm going to load up Internet Explorer. And one of the things I've noticed is that when you load it up, it wants to go to Bing, which is annoying. So you may actually want to change the homepage settings as well. So what I'm going to do is I'm actually going to connect to, I'll show options again, just so you can see it. So basically, I'm going to connect to this IP address with this page. I'm going to go here, and I'll do HTTP : I'm going to bring this over a little bit for everyone to see. 192.168.35.4.8080, and then I called it page. So I'm just going to call it page again. So for instance, if you were running this thing in a real attack, hypothetically, or something like that, you might try and see if you can get this link into a whole bunch of your, maybe your target is a company. As many of the people you can find on LinkedIn, send them unsolicited, link like this or something like that. The way I look at it is always every target, every individual human target has a probability of being able to click on the link. So naturally, you increase the number of targets, you increase the likelihood that at least one of them will click on the link, being how probability works. So then I can go. One of the other nice things too is while this is going is, let me actually go down here, you can see that it is actually dumping out some comments right here. So, sometimes I may end up having to do something like this. There it goes. So then, from the user's perspective, they're still waiting for the page to load. They might have had to click like compatibility mode to get the, to get the thing working, or just wait for a long period of time, something like that. So from their perspective, they don't know why, but didn't want that to happen. Give me a second. I mean, to maximize that. So it's still basically cycling for the user. They're still waiting for it to load. They might even try and close it, but this thing right here tells us that we actually established a connection successfully. Oops. Sorry for those of you in the classroom. The zoomed in window keeps bouncing back and forth and doesn't follow my mouse very well. So this thing says that we got a active session. So what I can actually do is I can do like this. So there's actually a possibility for you to actually, you'll see that while it's running, it's actually doing all that stuff in the background, still giving me command line access. So if I wanted to, I could be kicking off like 5 different attacks inside of Metasploit here. So then I can go and see of the ones that succeeded. I can dump like this, and then I could choose to log into one of those. And now I have like interactive access to be able to work on the system. So for instance, I can do a task list to get basically effectively a PS. So one of the nice things, I'll kind of do a quick help here. One of the nice things that Meterpreter offers is it gives you a command line shell like this, so it gives you a bunch of backdoor commands for you to use. This isn't DOS, and they map a number of really common Windows concepts to their corresponding command in Unix. So an example of that is all of these, the file system commands. There's also some other more advanced stuff in here as well. You might have noticed like there's the microphone and webcam and all that stuff. There's a git system, attempt to elevate privilege to that of the local system. So maybe I want to try that, right? So failed. So, you know, however I have that VM configured, it's very difficult for me to get administrative or system rights or service rights on there. But I might be able to do this, right? Or maybe not, who knows? You know, but that basically, I'll say the hash dump is basically if you want to be able to allow somebody to, or I should say, if you want to be able to steal passwords for anyone who's logged into that machine, that's one step in that direction. We can get into how that stuff works later on in class as well. But, you know, I might want to be able to do this to actually get like a shell as if I were loading command.com or cmd.exe on there. So I can actually exit out of this. The other thing I can do is I can exit out of this, which will shut down the connection, and it'll actually close the program on the remote side as well. Another thing that will close the program on the remote side is if for some reason there's like a disconnection. But one of the nice features of this is as soon as the connection is severed, it immediately tries to basically the user's web browser is actually stuck in a loop, trying to refetch the shockwave file and basically keeps trying to reinfect itself. So this is another feature that they've added. This is another technique. So this isn't Metasploit. Metasploit's not making the user system reconnect. One of the complications that you have when you are, or I should say an adversary has when they're remote controlling a system, is that something might cause the user to get surprised and want to shut their system down, or the user may unplug their system and go to a coffee shop, or the user might go home for the day or something like that. Maintaining presence on the system is a general kind of problem set that a lot of the attackers have to design for. They design malware that behaves in a particular way. So what you saw me do there is I closed the session. I disconnected that session that was going on. The software that's running on the user system is already configured to keep trying to basically refetch the exploit and in order to reinfect itself. Basically so that if there's any unexpected interruption, next time the system has internet access, it's going to automatically try and connect back. I just need to make sure as the attacker that I keep this Metasploit or a Metasploit session running right here. So, let's see. So I can look at this, and now I've got session 2. So session 1 is gone, session 2 is here. The other thing I can do from right here is I can jump in if I want to. I can upload stuff. So see, yep, here we go. I can upload files. So for instance, if I wanted to, I don't know how much time, I don't have a huge amount of time left, but let's see. Great. So basically, I also have the shared folder, the same shared folder available here on my Kali system as well. So what I'm going to do maybe is look here, and maybe I want to go and put one of these things on there, like this thing, for instance, right? So maybe, so LCD is local CD. So this allows me to change my current directory both on the host as well as, or I should say both on the target as well as on my local host as well. So I think that works, yeah. And then on the user system. So the LPWD is my Kali system, PWD is the user system. If any of you are familiar with FTP, similar kind of command language there as well. So for instance, I can upload, we'll say rat.exe. Oh. So we'll see, maybe I can't do it. Oh, maybe I don't have access. Windows. I might not have access to this system. I might have to mess with it. Or, yeah. So, yeah. Well, basically, I can upload stuff. I haven't actually jumped into starting to upload things yet. But if I want to, I can upload. I can download stuff. So I can download like ntuser.ini. If I want to, I can bring that into my system, so it's a good way for me to just go and steal, documents as I want. Let's see if I can find Windows. Yeah. So, try and see. Users, see if the public works, right? Maybe I can upload to here, or maybe I can't. See, it failed. So there's something on there that's messing with probably still messing with the interactions, probably permissions or something like that I'll have to figure out. Yeah, I'm not gonna. I didn't expect to get this far anyways, but yeah. So the key thing here is that, and it probably helps if I scroll back in the scroll buffer here. So the key thing that happened here is that I am actually delivering a payload that's built out of this thing. So it's this Meterpreter program. So Meterpreter itself is a program that's running on the user system that is designed and configured to connect with these parameters here. So it's to keep trying to connect until it succeeds, and then when it fails, it tries to reconnect to that IP address and that port. Once that's there, it actually is configured to have this entire command language that I was using to talk to it, which means that the functionality that implements all these things, so all these things themselves have some sort of code and maybe even some messages and stuff like that, is actually running on the user system that correspond to each one of these commands. And many of these commands may not be very common things that you would see on a normal, well-behaving system in your environment, like these key scan, things, or the some of the webcam functions and stuff like that. So looking for this unique code, unique behavior, unique traits is part of the malware analysis problem. Yes.
So it's simply connecting to that page installed in the server.
Yeah.
And there's no notifications browser whatsoever.
Not in this case, mainly because I was using an older one. So as far as the user believes, so the question was, in this particular case, basically it just visited the page, that IP address / page, and then it actually has HTML that it serves. That HTML has, I believe, some JavaScript and also some tags, some embedded object tags. I forget exactly which one they use. we might actually be able to use source here, right? So actually has something that looks like this, which is some embedded items and everything like that. Explains how to get Shockwave Flash if you don't have it, and serves a actual file that's a Shockwave Flash document. So this HF, this thing right here, is the name of the file that was served up. From the malware analyst perspective, we would go through these things, and you've actually got many different files, many different artifacts to pick from when you're analyzing this particular event. We've got this HTML page here that's formed in a certain way that itself might be built off of a recipe that's unique. You've got this Shockwave Flash file that is basically, media data, but also has compiled JavaScript inside of it as well, because that's the scripting language under the hood in Flash that is basically a program, and a pretty powerful program at that. That would also be something to analyze. And then finally, that got an interpreter on the system, and pulling the interpreter out of memory or pulling it off of disk, wherever it happens to be living right now, that's a completely separate program. So the Shockwave Flash, that doesn't implement any of the Meterpreter commands that we saw. There's actually a separate program itself, which is the Meterpreter exe or Meterpreter shellcode, whichever one was delivered with this, I'm not sure, that actually implements all of those commands. So that said, I'm up on time now. So we will literally pick up where we're leaving off today on Tuesday when we come back, and we will fetch all of these files. I've actually pre-fetched some of them, but I'll also go through some of the tools that start to fetch some of those down, just so you can see what it's built out of, and we can go from there. All right.